Well, let's take a look at using generics, or as they're most often called, type parameters. Let's consider this way of creating an array list object. This is the name of the object right here. This is the name of the object. Now, if you'll look at that code we just had highlighted and compare it to this, the only difference is down here, this is between these two right here, and it's also right there. Now, what does this do, this type parameter? It restricts this object of this name to only permitting strings to be stored in it. Whether they're type object, and these have to be consistent, these have to be the same, whatever type object you say there, that's the only type of object you can store there. Now, this is sort of a safety thing so that you can catch errors at compile time when you might try to store something, some other type object there. Now, this has another advantage beside that safety type thing right there. When you go to retrieve objects from this array, they are really stored ultimately as object type objects. And so, for example, if you had put in a wrapper class double and you retrieve it, yeah, it's still got a wrapper class double in there, but it's really stored as an object type object, and you would have to cast it to store it back in a wrapper class double when you retrieve it. But if you use these type parameters, like if you use double, capital D here, to store all your wrapper class doubles in there, you would not have to cast it. So I strongly recommend that you do use type parameters. It'll make life so much easier. Now, we're going to look at a couple of examples here, and on them we're going to assume this has been done, that we have created an object of this type. It's a list type object, and what does this tell me right here is the only type thing that can be stored in it: wrapper class integers. So let's take a look right here at adding the number 13. Now, this is all you have to do. So the name of your object dot add, and then the argument you send it is 13. Aren't you glad it's today and not 2 years ago? This is what we formerly had to do when we had Java, or before Java 5.0 came out. Not too much fun. It's even worse if you look down here. In order to get something, now notice, because we built this object using type parameters, we do not have to cast it. It's going to come back as an integer. It's going to actually come back as a wrapper class integer, but auto unboxing is going to take over at that point and just store it as a primitive integer. Look what we had to do in the old days. Now, if you think this is hard now, oh my gosh, look what we used to have to do. It was just very tedious. So be glad that they updated it at Java 5.0 to make it so much easier and so much more straightforward. Now, one last thing I would like to mention while we're on this lesson is this chart at the end here of big O values for various operations, various methods in the list interface, and in particular that we use with array list. Many of them are not iterative at all. They have a big O value of 1. It just means it's a simple block of code that in no way depends on n, the number of elements stored in the array. That's what n is. But some of them do depend on n. Well, let's just look at this one here. Why would this one depend on n? Because when you add an index at some interior point, it has to scoot everything else forward. It just moves everything else up a notch, and that's proportional to how many things you have in the array to start with. And there's another one here that's dependent upon n. You ask if an object is contained there. It has to step through them and look at them, and that's proportional to n. And likewise here. So these come up on tests sometimes and are just useful things to know, but they make sense, and really you don't have to memorize them. If you just think about them, the big O values really make sense for what we have recorded here.